All right, welcome back. Let's talk about mass wasting in Arizona, shall we? Oops, a daisy. So, what are some facts as far as mass wasting occurs in Arizona? Well, there's been over 6,300 mass wasting features identified in Arizona. Whether that happened recently or way back in the geologic past, you can look at some geologic structures and see how things are kind of set up. Oh, it looks like this material kind of slid or flowed out. There must have been some sort of mass wasting event here, 500,000 years ago, 2 million years ago, whatever it may be. So there's been 6,300 of these features identified. Mass wasting in Arizona can be measured in inches per year, so very slow, creeping, slumping material, 2 miles per hour, things moving very, very fast. So we get all kinds of mass wasting. It occurs in all 15 counties of Arizona, or at least it's been documented to occur in all 15 counties, looking at all 6,300 plus of those events. Around half of all mass wasting events occurs on tribal lands, which is kind of interesting to know. There's a geologic reason for that. If you took the collective footprint of all the mass wasting deposits, all 6,300 of those things, so you look at the footprint, the area that they came from and that covered with the material that wasted them, that would create an area about 770 square miles, an area equivalent to that of Phoenix and Tucson combined. So that's a big area to cover in mass wasting material. So the red indicates a high incidence of landslides, so that's where they're likely to happen. So this is tribal land up here, but you can get some up here. Orange is moderate, yellow is low areas. But interesting to note, but again, what you see here is up in tribal land. So the reason you get a lot of mass wasting events up there is because the sedimentary layers that are exposed up there on the Colorado Plateau, a lot of those layers are made up of loose rock, loose material. So you get some moisture, some sort of precipitation, and because there's a lot of loose material exposed by nature of the rocks that are there, the geology of what's there, you're going to get a lot of mass wasting events. But this is kind of a hilly area, mountainous area. So, yeah, you need slopes. That's where they're going to occur. The dots show incidences of past landslide records, whether it's minor or major. So they do occur around the state themselves. This is just a handful. Some more recent landslides may or may not have heard in the news. I shouldn't say landslides, mass wasting events. So in 2020, along U.S. Route 88, which is just south of Roosevelt Lake, Route 88 is also known as the Apache Trail. If you've ever driven out that way, it's actually closed now. You can't get through it, partially because of things like this. So this was an event that happened. You can see this is a kind of very sheer cliff along this road cut here. You can see it looks small, but when you look at it up close, it's a pretty big event. What kind of mass wasting event does this look like to you? It looks like sheer cliffs. Looks like this material just kind of fell off and just fell onto the road. What do you think it is? Yeah, it could be that. It could be a rock fall. Yeah, so maybe a rock fall, a rock tumble, or maybe even a block slide. My guess is more kind of rock fall. It looks like there's a big chunk of stuff just kind of fell off. So it looks like rock material. Another more recent one in 2013, Route 89, with the 80s. $25 million of damage caused here to repair this. So this was kind of a before and after. So if you look at this, the slope is pretty steep. Looks like they built this road, cutting into this steep slope, and so when that happens, you can create things that are unstable. So it looks like it kind of scooped out here. It looks like it kind of went down and kind of out, down and out. What does that kind of look like to you? No, it's not that one. Try again. Rotational landslide? I think so, maybe. Without more information, it kind of looks like it has some sort of kind of scooped rotational direction to it. State Route 87, 87, 88, 89. Stay off the 80s. Back in 2008, $18 million of damage done. Again, it looks like this area, whenever this road was built, looks like maybe part of this mountain was, or part of this hill was kind of graded back, dug back to make room for this road, and in doing so made it unstable. So even over time, over years, over decades, that stuff can become loose and unstable and flow out. It looks like the heavy equipment's out, traffic's flowing. It looks like there's been a good amount of cleanup of this area already after this photo was taken. But it looks like some sort of flat slide, maybe translational landslide. That's what it kind of looks like to me. And then the most famous mass wasting event in Arizona is the Marcus landslide. I don't know if it's necessarily the biggest or not, but it is one of the more famous ones. So it's in Scottsdale. It's on the other side of the McDowell Mountains. So on the other side of McDowell Mountains, that's where actual Scottsdale and Phoenix is. So this is on the east-facing side of the McDowell Mountains. You can go here. There's a little hiking trail. You can kind of see it. You can go up here and walk on this slide mass here. But you can almost see where this material came from. So let me just outline the slide mass, the material that's slid out. You can see all of that, and you can see up here where it came from. It's called the scarp, or the head scarp. And notice that curved shape to the slide, so kind of curved up and then down. So what kind of event is that? A rotational landslide. Very good. Year number 1. Hey, speaking of that, that's the next part of the super secret code. I'm just going to say it one more time. I'm just going to say it once, I should say. It is the number 1. You got it? Okay. So the Marcus landslide, again, the head scarp, that's where all the material came from. And this whole slide mass kind of made its way down. Again, on the other side of the mountains, you can see Scottsdale and Phoenix, etc. So this occurred 500,000 years ago. The slide deposit itself is 1,650 feet wide, nearly 4,000 feet long, almost a mile long, and it stands about 100 feet above the valley floor. Like I said, you can kind of hike out here, up on top of it. You can see different type of rock formations. It's pretty interesting. It's enough material to fill 6 Sun Devil stadiums. That's the football stadium at ASU. It's enough material in the slide mass to fill 6 of those. Total weight, 25.8 billion pounds. So the reason this occurred 500,000 years ago, the climate was much different. Much colder and much more moist. So a lot more water, colder temperatures, could have been also some of that freezing water. But something as simple as a lightning strike, enough vibration, enough energy to cause something to move. But yeah, it was a different environment, much more moist, a little bit cooler, about 500,000 years ago. So that probably helped in this whole rotational landslide we now know as the Marcus landslide. So some other dangers around Arizona. As recently as July 15th of 2017, a post-wildfire flash flood in the Tonto National Forest developed into a debris flow. So remember, flash floods, a lot of water, typical in desert areas, arid regions, mixing with dirt and other material can create debris flow. So a flash flood is just mostly water. A debris flow is when that water mixes with dirt, rocks, trees, whatever, and kind of flows. So as far as deaths due to mass wasting events, again, back in 2017, there was a post-wildfire flash flood. So there's an area, very barren, ash, burnt stuff. It's a lot of loose material. Flash flood hit an area, kind of picked up all that material to turn into a debris flow. This debris flow swept through an area called Cold Springs. There's a swimming hole there, and killed 10 people. This was just outside of Payson. So you get these channelized debris flows, and flash floods are responsible for most mass wasting related deaths in Arizona. So this is the Cold Springs. This is the swimming hole. You can see some kind of people down here. So you can imagine, remember flash floods, when we talked about flooding in the previous unit, they come on real fast. They come on real quick. And you don't even have to be in an area where the storm is in order for a flash flood to get to you. I mean, it could flow for miles the storm could be miles away, create that flash flood. That flash flood down that channel, down that stream channel, can just come ripping right down. And that's kind of what happened. There was a family, just they were all swimming, and the debris flow, because it was water mixed with mud and whatever, kind of came in and just killed them. Didn't even expect it. So here's some videos I want you to watch, not necessarily on the particular event itself, but just what a debris flow is, what it looks like. Since we are in Arizona and flash floods are prevalent, it's a good idea to kind of see these things, what they can be, the damage that they can cause. So it's a flash flood plus a bunch of stuff mixed in. When those debris flows settle, it's not like it's very thick stuff. This is a stopped solidified debris flow. So when that material stops, it's not like just water and it seeps into the ground. No, it's full of material. So it can form essentially a thick mat of now debris flow fill. So this was a debris flow that went across, looks like some dirt road. They eventually dug through it, but that's what it looks like when debris flow when it kind of comes to a stop. So let's go ahead and pause there. When we come back, we'll talk about some of the biggest, the baddest mass wasting events to ever hit the Earth that obviously had some very negative impacts. So we'll talk about that. And this next section will be a little bit longer, so it might be broken up into a few videos. So make sure you're ready for that. I'll see you back here in just a minute.